So today will be our last lectures in this semesters. And about the lecture on Friday will be a review sections. So in that review section, I will summarize the most important concept we have taught in this semester, and I also will pick selected problems in our previous homework set, so you can focus on this homework problem, so you don't have to go back and repeat all the homework. So in the previous lecture, we studied about the models of atoms. So back to 2000 years ago, Democritus proposed that the material, the matter, is made of individual tiny things, and they cannot even be divided into smaller pieces and cannot even seen by our eyes. So this model actually was ignored until 19th centuries. The John Daltons performed some experiment to verify that actually the matter is made of atoms. But I want to emphasize is that atom is not the smallest structures. So I'm not sure, have you still remember that? In the first lectures in the first semesters, I start the introduction by giving you the sense of feeling of the structure of the matter. So the matter can be divided and they will see the structure of the atoms. So this will be enough for this class. But intrinsically, from the particle physics of view, each atom is made of the nucleus and electrons orbiting around the nucleus. And for the nucleus, it is made of the combination of the proton and neutron. So when you study the periodic table, the chemical properties of the elements is determined by the number of the protons. But in the particle physics, we even try to divide the proton and neutron into a smaller element, which is the quark. So in reality, what happens is that the quark is the undividable element, which was proposed by the Democritus. So here is the timeline when people discover the structure of the atoms. So you can see that people find out electron first, and the nucleus, and neutrons, and eventually quarks in the neutron and proton. So the advance of the science was step by step. So this is our current understanding of the matters. So everything you see in the nature, no matter the stars, your body, the table, even the light, everything now can be decomposed of these fundamental particles. So it seems it is a more complicated models than the original first model. So we have 58 elementary particles in the natures. So don't worry about that. How do we get the 58? So the simple concept is that all the material is made of the quarks, and all the nucleus is made of quarks. And we know that there are electrons orbiting around the quarks. And this is the so-called force carrier in charge of the electromagnetic force, strong force, and weak force. And also, they have three families of the quarks, three families of leptons. So now it seems that if we compare with the first model of the material, it seems original people guess it is made of 4, but now it is 58. So sometimes correct theory doesn't mean they are easier or simpler. So this is a so-called STEM model of physics. So let's have a first conceptual quiz, which is a trivial one. So we know that the periodic table is made of elements, and every single element is made of the same atoms. So how many elements we have? So we know that we have more than hundreds. So now, at the late 19th centuries, people invent another model of atoms. They thought that the electrons around the nucleus actually is embedded as a Putin's model. So the electrons are embedded in the mass of the positive charge. So all the orange area here are the so-called positive charge, and the electrons are embedded on the surface of that. So which mean that the distribution of the electrons are uniform on the surface, and the most of the space of the atoms is occupied by the positive charge, which is the nucleus. So apparently this is a wrong model, but how do people realize it is wrong? So they run this so-called the charge colliding on the gold foil experiment. So they launched some alpha particles. So alpha particle is not even a small one, it is a helium nuclei. So interact with the gold foils. So gold is a more complicated structure element. So if the previous Putin model is correct, ideally, most of the scattering will distribute it evenly in all directions. But eventually, people find out, no, the result after the scattering of the alpha particle with the gold atoms, there are a lot more large angle scatters. So what does that mean? It means that originally, if all the mass, all the space is occupied by the positive charge, which is the nucleus, then ideally the distribution should be uniform. But now, most of the events are large angle scattering, which means that the positive charge actually was centered at a very tiny region. So, in fact, the correct model is the so-called solar system one. So, the center of the nucleus, they only occupy a very negligible size of the space. And all the rest are empty. So if you check the first lecture in our previous semester, if you try to think the structure of atoms in terms of the size of ping pong ball, then if the nucleus is the ping pong ball, then the size of the electron is a bacteria. And the distance between the bacteria and the ping pong ball is 1 kilometer. So intrinsically, based on the previous experiment, the Rutherford proved that the structure of atoms is very empty, and most of the charge, positive charge, was at a tiny volume at the center. That's the reason we all have a large scattering, large angle scattering. So now, if this is the picture, what's wrong with that? So even the pictures I provide you is incorrect. So even though now most of the positive charge was at the center and with the electron orbiting around that. But do you remember that? So electron carry the negative charge and the nucleus carry the positive charge. So positive and negative charge attract each other. So why the electron will continuously orbiting around the nucleus without collapse? And also, we know that the orbiting electron is in a circular motion, so they have the acceleration. So we learned that from the concept of electromagnetic wave is that when the electric charge is acceleration, then they will radiate the energy outward. They will give the energy outward as a light. So if they lose the light, eventually, once again, they will collapse. So this model actually cannot be understood in terms of the classical physics. So another thing is that based on the picture we just have, if the electron is orbiting around the nucleus, when they lose the energy, the spectrons, the radiation emitted by the electrons losing the energy should be a continuously spectrons. But in fact, what we find out in nature is a discrete spectrons. So let me summarize two things, that this solar center model is more close to realistic situation, but they cannot explain why the structure of an atom does not collapse. And also the spectrum, the light emitted by the electrons, is discrete, not continuous. So here you can see that if you try to put the hydrogen gas within the electric field, the hydrogen will be excited and they will emit the light. And when you try to measure the spectrum, this is the light emitted by the hydrogen. It is discrete, not continuous. So what is the continuous the spectrums? This is a concept of continuous spectrum, yeah? But what happens is that the spectrum emitted by hydrogen is discrete symmetry, discrete. So this is something people cannot understand based on the classical physics. So now let's have another conceptual quiz. So this one I will give you the answer directly. So we know that there are some elements was created when the universe was formed. So which element is most abundant in the universe? And the answer is hydrogens, because the hydrogen is the simplest structure of atoms could be formed. So usually this is the first one formed within the core of the star. So this will actually play a crucial role, is that for a lot of stars, we can observe the color of that. So how do we know the color, or how do we know inside the core of the star they have the hydrogen atom there? Because we cannot drive a spaceship and go in there and detect it. So we basically just detect the light from the stars. So what we find out is that if you try to detect, for example, the spectrums from the nebula or from some stars, their spectrums will show you that what kind of element exists there. So for example, if they show you a spectrum here, then we can for sure say that there are some hydrogen atoms within that star. But even at this moment, I did not explain is why the spectrum is not continuous, it is discrete. So we have to understand this one based on the quantum physics. But before that, let's try to understand this spectrum a little bit with a little bit more details. That is that different kind of elements have different kind of patterns of the spectrums. And all the spectrums emitted by the different kind of elements, all the atoms, are all discrete. So what happens is that when the light passing through that element, the energy will be absorbed by the elements, and there are some effect, which is a quantum effect, happens. The electron will be excited because they receive the energy from light. So they will jump and be excited and then release the energy. And the energy release will be emitted outward as a light. So that's the reason there is an emission spectrum, and which is discrete for the atomic hydrogen and other elements. So before I explain to you using the concept we learned in the previous lectures, people find out this is the formula to describe the atomic spectrum for the hydrogens. So the wavelengths can be described by this. So what is the R? R actually is a constant. So it is a very big number, but you can simply just treat a constant. And here, this formula, I have a 2 here. So if you have a 2 here, it means it is a Balmer series of the spectrum lines. So the reason is that the number here corresponding to the particular orbit in the quantum systems. And this orbit is discrete. So there is no orbit with a quantum number 1.1 or 1.2. They are continuously. And the 2 means that they are jumping, the electron, excited electron, are jumping from the energy quantum number at n equal to 3, jump to 2, or from 4, jump back to 2. So which means the final destination is all n equal to 2 orbit. So this spectrum is discrete, and the wavelengths emit for each of the jumping can be described. So you can concede that from jumping from the n equal to 3 orbit to n equal to 2 orbit, they will emit particular wavelengths. And these wavelengths will correspond to one of the spectrum line here. So every single light emitted is unique. So this is how the spectrum is formed. So apparently here, 2 is a special case. So in general, to find out all the series of the atomic spectrum for the hydrogens, this n prime could be arbitrary from 1, 2, 3, 4. And now this n definitely should be higher than the n prime. So if the n prime is 1, then n will start from n prime plus 1, n prime plus 2. So that's the reason here n start from 3, because your n prime is 2.